Alright, Andre, I would like you to design YouTube. Use the video sharing platform. Awesome. Let me just take note over here. I might have a few questions before we get started. So what features are important here? Yeah, use the basic, and user can upload a video and also users around the world can watch the video. Talking about clients, do we need to support a web application and also mobile apps, televisions, and so far and so on? Yes, we can focus on that three if you want for now. So basically will be mobile apps, web browsers, and also smart TVs. Perfect. So let me just take note over here. Do you have an estimation of the daily active user or monthly active users for this application? Yeah, we are expecting to have a traffic of 5 million daily users. All right, so it's going to be 5 million daily users. Do you have an estimation of how many users are uploading videos, or is something that I need to assume? Yeah, we can agree on that. What do you think? Yeah, we can agree that only 10% of the active users upload videos per day. What do you think? Sounds good? Yeah, that sounds reasonable. Great. So let me just upload videos, and we have only 10% of the users. Do we have a requirement about the size of the video? Yeah, this platform only focuses on medium videos, so probably it's going to be no more than 1 gigabyte. I guess encryption is required. Yeah, that's correct. We also talk about resolutions. I imagine we are expecting to have any resolutions and formats. Yeah, that's correct. Yeah, I have one important question is, can we use some cloud services, like for example, AWS, or do we need to design everything from scratch? Yeah, that's a very good question. I believe that designing from everything from scratch is going to be unrealistic for this interview. So yeah, please go ahead and use any tools available outside. Great, so I now have a better idea of what features we need to focus, basically upload and watch videos, and have an idea of the traffic. So let me just go ahead and write a small back to envelope estimation so we have an idea that we're on the same page. Yeah, so one of the important points is that we have 5 million daily users, so I can guess that in average a user watch around let's say 5 videos per day. So if we already agreed that only 10% of the users upload videos, so we are talking about 400k new videos per day. Alright, so we can now calculate the total storage, but before that we need to calculate the average size video. So we can say that if the maximum is 1 gigabyte, the average size video is going to be around 500 megabytes. That sounds like reasonable. Yeah, that sounds reasonable. Great, so we can now calculate the total storage. That is going to be basically for 500k videos per day times 500 megabytes. So that is going to be around 240 terabytes. The total storage per day using a CDN that we are going to discuss later in the system design. However, we can say that the cloud front cost per gigabyte is around $0.02. And if we say that an average user per day watch, let's say around 5 videos, that sounds like a good assumption. Yes, please, that sounds reasonable. So take into account we have an average of 5 videos per day and also 5 million active users. So we can say that basically the total cost for streaming videos is going to be equal to 5 million times 5 times the average size of a video is going to be 500 megabytes. So we can probably convert it into gigabytes to easy calculation. So it's going to be equal to 0.5 gigabytes, and the cost that is basically 0.02 per gigabyte. So that is going to be equal to around $250k per day, only to stream videos. Alright, so now that I have a better idea how the system works, let me just go ahead and do to a high level design. So as you mentioned, the system is going to consist on two parts. The first one is the uploading a video, and the second one is that user can watch a video. So let me just talk about first about upload a video, and then we can discuss how user watch videos. Great, so the first thing that we can draw in our system design is probably the clients, and the clients, as you mentioned before, can be mobile apps, web browsers, smart TVs. So users from these three platforms can upload videos. So it's talking about availability. We probably need to split servers around different regions, so we'll be able to escalate in and escalate out depending on traffic. So we are going to need a lot of volume in order to handle the requests. So when a user uploads a video, is going to do two steps. The first one is going to connect to a upload service. So let me just write down that over here, and also is going to connect to a metadata service. So we connect from these two services from the load balancer. Pretty much the metadata service is going to store the information into two databases. The first one is going to be the metadata DB, And obviously, and similarly, we are going to need a metadata cache DB. So let me just change the color on these services. Great. So from the metadata service, we call these two databases, and the upload service is a very critical piece on this system design. And as we discussed before, we can reuse cloud services tools. We can use a service available on AWS called pre-signed upload URL. So this is going to be a pre-signed URL that we can generate here and return back to the client so they can upload directly videos to an S3 folder. So the way that works is basically we install a service using an SDK, and we just basically create that pre-signed URL and return back to the user. So we return back that pre-signed URL to the user, and then they can upload the assets from there, and we don't need to worry for anything about, for example, losing connections or things like that, because the client in the mobile app or the web app is going to handle these kind of situations, and they can restart the upload when they recover the connections. Another huge advantage of this approach is that the video is going to be uploaded directly to S3, and we can react with an event when the video is successfully uploaded to the S3 folder, and we can do that also asynchronous. And the way that works is basically we can drag another system here that is going to be basically S3. So the user upload the video to S3 directly with the pre-signed URL. Next, we are going to react to this event with transcoding service. So we react to this bit basically using an events available on S3, and the transcoding service are going to basically split any job that we need to do. So the first one is going to send all of this into a queue. So when the transcoding tasks are finished, we can push that events into a queue. So we can call it something like finished queue. Once we push event into this queue, that means basically the videos are going to be ready. So let me just group this back, and we can have another workers here, like for example, finished service, and we can connect this from this queue. And the main task from this service is going to be basically process the metadata. So we can also process metadata from videos that are finished, like for example, how long is the video, the size. Also, let's say for example that we created a screenshot or watermarks from the videos. So this is a great place in order to process that kind of metadata that it's different from the metadata that the user upload, because the user upload is very basic metadata, like for example, the name of the video, descriptions, tags, keywords, things like that. However, from this metadata process, we need to extract information related specifically from the video, but we are also going to use these metadata databases that we have here. And we might need to do the final step, that is basically storing everything from the transcoding service. We are going to need another S3 object storage to basically just put the transcoded videos here, transcoded assets. So it could be anything, different resolution from the video, screenshots, things like that. All right, so from here we are going to store that bit here, and we are going to need also upload everything to a CDN. So we can use a CDN over here. Let me change the color, and we can connect this to here. And this is the most important bit for the next diagram, that is basically how users are going to watch the video. And if you want, I can discuss a little bit more deeper about CDNs in a few minutes. So at the very high level design, this is how the upload workflow is going to work for a YouTube. So let me know if you have any questions. Yeah, absolutely makes sense. So I would like to go deep in the transcoding service if you don't mind. Sure, absolutely. So let me just go ahead and finish the high level design on how users are going to watch videos, and then we can use into the transcoding service. All right, so let's go ahead and write down here the high level design for watch video. So actually this is going to be the easier part. So basically we are going to need a client, and we previously discussed that it could be a mobile app, web app, or smart TV. So from this client, the user are going to be able to select a video and start watching. And basically the way that occurs is in a stream way, because the video is not downloaded to the device. Because if that's the case, it's going to be super slow to watch a video, and nowadays the latency to watch video is basically instant. So the feeling that you can watch a video right away is because we stream the video from the CDN. CDN is a cache layer for assets, and it's very fast because CDNs offer edges around the world. So a user on Europe can watch instant videos same as a user on United States. Besides, the user are on different locations, CDNs are going to offer a cache on that specific region. So let me just draw the CDN, and from here we are going to stream the video. Alright, that's great. Could you please explain a bit how the stream works? Yes, absolutely. Streaming is a standardized way to control the data transfer for video streaming. And when I say standardized, it's basically because currently there is a few protocols available to stream videos. One of the most popular is the MPEG dash, which basically means moving pictures per groups. For that basically stands for dynamic adaptive streaming over HTTP. Apple also has their own stream protocol, which is called HLS, which basically stands for HTTP live streaming. There is also available Microsoft Smooth Streaming, and Above also owns the Above HTTP Dynamic Streaming, or HDS. And as I mentioned before, basically this is going to send in a stream way, bit by bit, the video on demand. So the client on the device is going to show the video right away instead of download the whole video that is going to take longer. Great, so we can now zoom in the service that you mentioned before. So you are interested to know more about the transcoding service, is that right? Yeah, that's correct. Could you please tell me more about that service? Yeah, absolutely. So basically we are going to be focusing on the transcoding service once the original video is uploaded to S3. Great, so let me just zoom in on this case here. Let me just add a label here. Alright, for transcoding we can talk about a series of steps before we can display a video in our platform. So in this case YouTube. So usually the user is going to record the video from a mobile device or from a camera, and then they are going to upload the video to our platform. So what we are going to do is take that original video and we need to transform that video in different bit rates because we want that video to play smoothly in our platform. So we want that video to be fast. What we need to understand about bitrate is basically a higher bitrate generally means a higher video quality. Also, many devices and browsers only support certain type of video formats, so we also need to think about compatibility. Also, we need to think on different scenarios where the video is going to be streamed. Chances are that they are streaming the video in a very low network bandwidth. So in these scenarios, the client needs to bring the opportunity to switch from different resolutions so the video can load faster. Also, we can apply some codecs. These codecs help to compression and decompression. So we can use different codecs, like for example H264 or BP9 or HEBC. Alright, so what we need to understand here is that transcoding is very compute expensive. So for sure we need to do all of these tasks asynchronously. Chances are that we need to also process, like for example thumbnails for videos, create watermarks, extract metadata, improve audio quality, and so far and so on. So we need to do a lot of tasks, and we can have some level or orchestration for all these tasks using a directed acyclic graph. So let me just write down here, and with a DAG we can define tasks and stages on the different processes that we need to run on our transcoding service. I know Facebook also use a directed acyclic graph, so we can use this tool on our transcoding service. We are going to have first our original video. Next, from our source we are going to have basically three tasks. The first one is going to be video, audio, and metadata. This metadata is a little bit more about the video, like the length of the video. Chances are that we can also process subtitles and things like that. But we are not going to focus on metadata for now. The most important ones for transcoding is video and audio. So video is going to have their specific tasks. So let me see if I can write down a few. Obviously we need to inspect the video for inappropriate content. Also here we can create thumbnails. The most important one, the video transcoding, watermarks, and so far and so on. All these tasks can be run in parallel, so basically we can have a container like this and we can start connecting our graph. So it's going to be something like this, and on video we can run all these tasks in parallel. Actually, the most important one is the transcoding service, where we are going to improve the video quality, applying different codecs and also video compression. For audio we are going to have a specific task, which is basically going to be audio encoding. And next, when we have everything ready, we are going to have the final stage or the final step, which is going to be assemble everything. So obviously it's going to be joined with this output from the transcoding path, and we can assemble the output from that step. So the good thing here is that we can run all these tasks in parallel, and that's it. We have our transcoding service model in a directed acyclic graph. Alright, Andre, thank you. Is there any other critical section that you feel that we can discuss before we move to the end of this interview? Yeah, sure, absolutely. If we go back to envelope estimations, we can see that we are going to spend a lot of money using CDNs. So I wanted just to talk bit about how we can improve or how we can decrease costs using the CDN. So the first point that we can use to improve this is basically try to use the CDN only on the most popular videos, and the other videos can be stored in a high capacity storage service. Yeah, another idea that comes to my mind is that not all videos are popular in all the countries. So probably we can use the CDN only on videos that are very regional. So let's say, for example, a video is very popular only on South America. So probably we only need to use the CDN on that area. All right, that's great. Very good points. Thank you, Andre. Alright, so before we finish the interview, I would like to give you a quick summary of what we have discussed today. Great, so first of all, we are trying to design YouTube with a 5 million daily active users. Only 10% of the users upload videos. So we do a few assumptions, like for example, the video is not going to be more than 1 GB and so far and so on. And we estimate that we are going to spend about 250k per day. But however, we have 3 points here that we can potentially help to decrease the cost. And we discussed about the pre-signed URL service from AWS, where the user is going to log in via REST API, request a pre-signed URL. We generate the pre-signed URL here using an SDK from AWS. We return the pre-signed URL to the user or the client, and they are going to use that in their devices in order to upload the video. Once the original video is uploaded to S3, basically we are going to have an event that is going to be raised and is going to be taken by the Transcoding service. The Transcoding service are going to use a directed acyclic graph in order to accomplish all the tasks that we need to do on the Transcoding, like for example tasks for video, audio and metadata. So we are going to generate different resolutions of video and so far and so on, and we are going to store that everything on S3. That transcoded video with a better quality and better encodes are going to be uploaded to CDN, and the CDN is going to be basically used by clients to stream to their devices. And once we finish with the transcoded service, we can upload or update metadata in the database. The other way to set metadata to the video is when, for example, the user wants to update the title, description, tag, things like that. They can use that via REST API. They can also update the metadata via the metadata service and update the database directly. Great, so we also talk about how the CDN works and how the stream works. Basically, we are going to send the video stream by stream instead of download the whole video into the device, because that is going to be very slow. So users can watch video very smoothly and fast. For the transcoding service, we talk about that we are going to use a directed acyclic graph in order to run tasks in parallel, and that is going to split basically on 3 main tasks: video, audio and metadata. For video, we can run tasks like inspection, thumbnail, transcoding, watermarks and so far and so on. Once the video is transcoding, basically we are going to merge that with the audio encoding and assemble that output video. And I think that's it. Please let me know if you have any other questions. No, I think that makes a lot of sense. So I have now all the information that I need. So thank you, Andre.